Hey, how's it going, sir? So this is the video for question 2 of the Metabolism CPT, where I had to explain the pathway NADH takes along the electron transport chain. So after the Krebs cycle, we're going to be left with 8 molecules of NADH over here. They're going to be in the mitochondrial matrix, and then they will enter the inner mitochondrial membrane in complex 1, which is known as NADH dehydrogenase. Once it's in complex 1, it's going to be broken down and oxidized, and it will lose its electrons. Those pair of electrons will then move along the electron transport chain with the electron shuttles ubiquinone and cytochrome C, right? So ubiquinone will bring the electrons from complex 1 to complex 3, and cytochrome C will then bring the electrons from complex 2 to complex 4. And in complex 4, the electrons will then be used to create a molecule of water. There's also the intermembrane space H plus gradient or hydrogen gradient, which will then be used here. So once the electrons travel into each enzyme or complex, a pair of hydrogen ions will be pumped into the intermembrane space, right? So as it's in complex 1, complex 3, and complex 4, so a total of 6 hydrogen ions will be pumped into the intermembrane space. One pair of hydrogen ions will then be used to synthesize a molecule of ATP. So that being said, one molecule of NADH has enough energy to yield 3 molecules of ATP. So in total, since we have 8 molecules of NADH, we have enough potential energy to synthesize 24 molecules of ATP. And that is the pathway NADH takes within the electron transport chain. Okay, thanks.